Hi all. So welcome to the fourth question from the practice exam 3. And basically this one's going to be my correlation one, right? So kind of a little bit of everything. So we're trying to figure out the correlation of x plus 2y and x plus y. Here we're told that x and y are independent. So they're independent of one another. And that they have Erlang distributions with shapes 2 and 3 and rates 4 and 5. So what does this tell me, right? So if I know they're Erlang, remember that the formula for Erlang, or the expected value of x, for example, this is just the shape over the rate, right? So in other words, here we have 2 over 4, which is 1/2. And the expected value of y is 3 over 5. Similarly, we know what the variance is, right? The variance in this case is the shape over the rate squared. So in other words, we have 2 over 16, which is 1/8. And the variance of y is 3 over 25. Easy peasy. So correlation, right? So what is the correlation? Let's kind of call ourselves what this is. X plus 2y. This is the covariance of x plus y, x plus 2y, over the standard deviation of x plus y, and times the standard deviation of x plus 2y. So let's kind of do the standard deviation of x plus the bottom things first, because those tend to be a little easier, right? So the standard deviation of x plus y, this is equal to the square root of the variance of x plus y. And now here we can note that they're independent. So by independence, this is equal to the variance of x plus the variance of y, which we know, we have this above. So this is just the square root of 1/8 plus 3 over 25, which putting into a calculator would give me 0.494975. Okay, well, what's the other one? Standard deviation of x plus 2y. Well, this is almost the same, var of x plus 2y. And here, by independence, again, I can split these up. I can bring this 2 outside, and remember when we bring it out, we square it. In other words, I have 1/8 plus 4 times 3 over 25. So in this case, what we end up getting is 0.777817. Okay, all that's left is covariance. So what is the covariance of x plus y, x plus 2y? Now here, if you recall the definition, you can use any definition that you prefer. Here's one of them. Anyway. So we have x plus y times x plus 2y minus e of x plus y times e of x plus 2y. So here, if I do the multiplication, I have x squared plus 3xy plus 2y squared. Minus, here again, I can do linearity. By linearity, I have x plus y, no, e of x, oh my god, plus e of y times e of x plus 2e of y. So what's the things that happen here? Here I'm left with e of x squared, again by linearity, plus 3e of xy plus 2e of y squared. Then I'm left with minus this right hand side, e of x squared minus 3e of x e of y minus 2e of y squared. Okay, this and this are the variances, right? So this is variance of x plus 2 times the variance of y, right? And then here, this part, e of xy is equal to e of x, e of y by independence. Therefore, these two middle parts, this and this, get canceled, right? They're opposite of one another. It's coming from this. And so the covariance, we also know exactly what this is, right? So this is 1/8 plus 2 times 3 over 25. So in other words, this is roughly 73 over 200, which is equal to 0.365. Now, as a side note, there's an easier way to do this if you remember the very, very, very last lesson we did, bilinearity. So if you're looking at bilinearity, what you have is x plus y, and then x plus 2y. This is equal to the covariance of x and x plus the covariance of y and x plus 2 times the covariance of x and y plus 2 times the covariance of y and y. Now the covariance of one thing by itself is always just the variance, x, and this again will also be that, 2 of y. And these two, covariance of x, y is equal to covariance of y, x is equal to 0 since x and y are independent and therefore uncorrelated. Right? They're not correlated with one another. So in other words, this was much easier to calculate than trying to do this long multiplication, whatever. So bilinearity is definitely useful for this. But okay, so we have this number. At this point, all we have to do is plug in. So correlation of x plus y and x plus 2y. This is equal to the covariance of x plus y, x plus 2y, over standard deviation of x plus y times standard deviation of x plus 2y. And here, if we kind of recall these numbers, the covariance was equal to 0.365 on top. The standard deviation was 0.494975 times the right-hand one was 0.777817. Plugging this into a calculator, we have roughly 73 over 77, and for some reason I did not calculate what this is exactly, so let me quickly do that while I'm talking and pretending I know exactly what is happening. Bam! 2. So this is our correlation. So they're very highly correlated with one another, which makes sense because they're almost the same variable. Okay, so that is, this should be an 8. There we go. So that is it for this topic. Oops, I should zoom in so I can get this higher. Yeah, so that's it for this problem. So as you can see, all the problems are relatively easy. They shouldn't take too much time. So yeah, that's it. Good luck on the final exam. I believe in you all. And yeah, that's it. Have a good day. Bye.